Greetings, everyone. This is Jeff Wilkerson, professor of physics at Luther College, bringing you the next in our series of what to look for in the night sky. It's June 17th. We're talking about this time around, beautiful summertime. We're located here in the northeast corner of Iowa in the United States. It's beautiful countryside around here. A lot of people come visit us to float our river that runs through town, to hike in the woods, and to bike the woods that are around here. And it's just a great place, a wonderful time of year, a great place to get outside and do things. But we have dark skies too, and so that's a wonderful asset we have here, and a chance to get out and see the stars and to see the Milky Way and the planets, the glow, the northern lights that people saw a few weeks ago that we saw very well right here. But this week, not so much because of the moon. We talk about this every month. About 1 week typically each month is pretty washed out by moonlight. We have 2 weeks that are impacted pretty good, but 1 week's really washed out, and that's this week, the week of June 17th. It was going to start. The moon's going to start about 80 to 85% full, and so it's big and bright already to start the week on the evening as it gets dark on the evening of the 17th. When it's that close to full, it's up most of the night, so it runs into the morning of the 18th. And it's closing on the stars of Libra, and we've looked at Zubenelgenubi, the southern claw, that translates as, and we've looked at that before, this star, because a lot of objects in the solar system, the moon, slides right over the star every once in a while. It's going to pass south of the star this time around. But as the night wears on, the moon's going to close on the fairly bright star. It's a 2.8 magnitude star there. It has a companion that is a 5.2 magnitude star. So it's got a 5.2. Remember, the magnitude system counts backward. 2.8 is a pretty bright star. We talked about that last week. 5.2 magnitude, not so bright. But its companion star is a good, a degree. You hold your finger out at arm's length, and that's about 1 degree. And you take that 1 degree angle and divide it into 60 even parts, and those are arc minutes. So we have arc minutes there, being a 60th of a degree. And its companion star, the companion star to the bright primary star, is about 4 minutes, almost 4 arc minutes away. That's really wide. We see stars where there's a chance alignment quite a bit with that amount of separation between them, where one star is closer than the other star. But to have them actually in a binary system, as part of a binary system, and to be components that are orbiting around the center, the common center of mass, very, very unlikely, very rare to have these stars that are that widely separated on the side, where you can take a pair of binoculars, and that's what I recommend you do. Take a pair of binoculars, let the moon guide you to this star in Libra. It's the alpha star in Libra. And so let the moon guide you to this star in Libra on Monday night. By the next night, it'll be over here. So if it's cloudy on Monday night, it'll just keep moving this way. So you can probably find this star, if you haven't seen it before, by using the moon one of a few nights. And then get your binoculars out and see if you can locate that companion star of Zubenelgenubi. Now, the primary star itself is we know they're moving across the sky. We do proper motion studies often to see if that's how stars are moving in space. And these stars are moving in the same direction at the same speed. So we know they're located together in space. That the likelihood of that happening just by randomness is very, very small. But the star's about almost 80 light years away from us. You got the star about 80 light years away from us. This system, that means to see these things that widely separated, there must be about 5,000 astronomical units between those two stars. The Earth is 1 astronomical unit from the sun. So that means this is a really, really widely separated system. So we don't see the orbit because it's so wide that it's going to be a very long orbital period. But we do see them flying through space together. Now, the primary star in the system is what we call a spectroscopic binary. So we look at take a spectrum, we break the light up into its component colors, and when we break the light up into its component colors, we see a lot of dark absorption lines in the spectrum. And sometimes you can tell there are 2 stars there because you can tell there are 2 distinct set of dark absorption lines. We call that a spectrum binary, where we see the spectroscopic binary, we see the two lines shifting back and forth due to what we call the Doppler shift. When one star is coming towards you, the other star is moving away from you. And the star that's coming toward you, all of those lines get shifted toward the shorter wavelength, the blue end of the spectrum a little bit. The star that's moving away from you, all those lines get shifted toward the red end of the spectrum, the longer wavelengths a little bit. And those things just keep walking around. You see those lines shifting back and forth like that. And that's what you see in the primary here. So we got a binary star that we can't see the individual stars. We can only tell there's two stars there because the sets of spectral lines that are moving around. And we've got a companion star that's really way out there, 5,000 astronomical units away from that other pair. So 3 stars in that system. Good to think about on the evening of the 17th and the 18th as the moon closes in there. It'll be past it on the next night. You can still be thinking about it all summer long. That'd be great. So you see the moon sliding off this direction. By the time we get to the evening of the 19th, into the morning of the 20th, the moon's almost full. It's still filling out. It's going to take another day or so to get to full beyond there, but it's really close to full. Big, bright, obnoxious moon, and it's closing on Antares, the big bright star and orange star in Scorpii we looked at last week. Go back and look at that. We talked about the stars in the head, and we looked at the globular clusters in this region. So you got sort of 3 stars. Sometimes people will mark 4 stars out here that mark the head of Scorpii and then the big long sweep of the scorpion's tail. We did this last week. But the moon is going to be closing right on Antares as this night wears on, getting really close to Antares here. And so Antares is a big bright star. This is going to be a beautiful pairing of a nearly full moon with a bright orange star. Now the moon is sliding right over Sigma Scorpii. Sigma Scorpii is about 2 degrees to the west of Antares. And Sigma Scorpii is also a multiple star system like Zubenelgenubi. And so Sigma Scorpii, when you get a chance, this isn't the night to do it because the moon is right on top of it. But another night later as the moon moves on this direction, what you want to do is find Sigma Scorpii out there and take your use your telescope to observe Sigma Scorpii. And Sigma Scorpii's got a 9th magnitude companion. So it's a fairly bright star, but its companion at 9th magnitude is fairly faint. But it's a third of an arc minute. Remember, it was about 4 arc minutes that separated the stars you can see here. Sigma Scorpii is pretty widely separated for any small telescope you have. And so you're going to see the secondary star about that 9th magnitude star, about a third of an arc minute away from the primary, the brighter primary star. Now, the brighter primary star here is a triple. You can actually find, you can't do that, but if you had the right equipment, you could find that you can split it into 2 stars that are really, really, really close on top of one another. It's going to take good professional grade equipment to do that, I think. But see that. And then one of those stars is actually also a spectroscopic binary like we talked about with Zubenelgenubi. So you've got 3 stars and then a 4th star in the system that is the star you can see in a small telescope here. Moon's going to continue to slide on by. By the end of the week, then, it's going to be starting to wane. So next week, we'll start with a lot of moonlight, again, washing stuff out. But it'll be coming up later and later and later rising. So if you're out in the evening, you'll be able to observe stuff. And by the end of the week following, it's going to be pretty much waned away. It's not going to be much of a problem. The planets in the morning sky, these are good for us to observe right now. You've got Saturn and Mars that are easily observable. By the end of the week, we talked about this a couple weeks ago. You've been hearing a lot about this parade of planets. Jupiter's finally becoming available to observe. So by the end of the week, at the beginning of the week, it rises, I'm going to say an hour and a half before the sun, which means you can pull it out of the glow of sunrise, but you got to time it just right, and you got to work at it. By the end of the week, it's rising a couple hours before the sun, and so you should be able to start to see Jupiter a little more clearly. But these things are pretty spread out. Saturn and Mars will be the other 2 brightest objects in the region there, and Saturn is a good, by the end of the week, it starts the week 45 degrees. 45 degrees separates Saturn and Mars. By the end of the week, that's 50 degrees. So 50 degrees is a pretty good angle out there separating them. It's another 25 degrees on over to Jupiter from Mars. So we're talking about 75 degrees, getting pretty close to a right angle that separates these. So by the time Jupiter gets up and well placed to observe, Saturn is already well across the meridian and is moving toward its setting. It's a long ways away from it, but it's moving in that direction. So right now, by the end of the week, The beginning of the week, Saturn rises about 1 o'clock. And by the end of the week, that's closer to 12:30. That depends on your local, where you are, your local time a little bit. So we're getting close. Given as late as sunset is right now, we're getting relatively close to being able to think of Saturn as an evening object rather than a morning object. Jupiter and Mars are still very much morning objects. So there's a lot of separation between these planets in the sky. But going forward, starting at the end of this week and going forward, we should have all three of those bright planets to observe for a little while. You got Saturn, you got Mars, and you got Jupiter. Mars isn't going to be well placed until probably 2:30 at the end of the week, maybe 3 o'clock at the beginning of the week. So Mars comes up a couple hours after Saturn, and so Saturn's already well up in the sky when you can start to see Mars, and then everything's moved across when you just start to see Jupiter at the end of the week. So we'll keep an eye on that. Check out a few multiple star systems here as you enjoy the moon passing through Libra and then Scorpius. And that's what we got for you this week. As always, thanks for watching, everybody.